GLSL storage qualifiers, input vectors, output vectors. We've seen these as input and output parameters. They're considered to be global parameters in our shaders, and they're also constant. If they're input parameters, you cannot change them. And the output basically goes to the next stage of the pipeline. Like here, our pass color becomes output from vertex shader and becomes input in our fragment shader. Uniform also does not change across vertices, and of course these are our transformation matrices. Also, uniforms can be vectors or even scalar values, just individual values. Vectors oftentimes describe position of sources of light. In-out can only be used with the qualifiers next to function parameters, and basically it makes this type of parameter work as a pointer to a value. So the function can use in-out as an input parameter, change the value, and upon return this parameter is expected to be modified, just like if it was passed to another function by pointer. Flat qualifier does not interpolate colors at all, so it's declared in both vertex and fragment shaders. So to demonstrate, I brought back our car model to load this in this latest laboratory project, and I'm just going to run it. Okay, so this is still, I kept the initial rotation to flip the car on the side. This is like minus 90 degrees that we use with the desk lamp. So now you can see the interior of the car, and I brought back our artificial color generation inside the vertex shader. So by default, all the interpolation of colors is smooth, and you can see that the colors are transitioning very smoothly from one vertex of each triangle to another. So here's the alternative to this, is to use the flat, which disables interpolation. In case if interpolation is disabled, the GPU chooses just one vertex with one specific color and gives it to the entire triangle. Okay, so this is the way this flat non-interpolated mode works. So let's take a look. We can take our color and say we don't want to interpolate, so I'm just going to make it flat. And then the input also has to be flat. They both have to be matching two stages of our pipeline. Okay, and we're just going to save all of this and run again. Okay, so now you can see how much more rigid everything has become. So every triangle, and you can actually see each triangle right now around this shape of the car. And for each triangle, just one color was chosen by GPU, and so it's using it. So it's kind of different, right? So it's now there's absolutely no interpolation of colors. Every triangle has the unique color which was chosen by the GPU. So this is the flat mode, and sometimes flat mode is useful when you're trying to debug your graphics. So because it's just basically makes things instead of transitioning them smoothly from one shade to another, here you can see just individual triangles in a more rigid format. And the smooth interpolation is the default interpolation, so we don't have to use it, it's just default, but this is also a keyword that you can use right here. Non-perspective is shown on the next slide. So what we have here is like a square or rectangular shape, which is made up of two triangles. Okay, and it just appears that the color over here differs from the color over here. So somehow there needs to be an interpolation done for every single fragment that composes this entire face. Okay, and so this interpolation may decide to go this way, like it's shown here for this triangle, but then choose to go the other way, basically like this way, for the second triangle. And it creates this absolutely unwanted artifacts that this is no longer anywhere close to a smooth interpolation. You can still see like a ridge, like unwanted break in the midst of this entire shape. So this is the perspective interpolation, and this is the interpolation without perspective. And so this is another keyword that you can use with shader variables. Of course, you would expect that mathematical functions for scalar values, vectors, and matrices are all built in, just like we can import them, or rather include them from C++ standard library. Here they're just built in, and they're just available logarithms, exponents, square root, also power, of course, all trigonometry is here, conversions to radian, from degrees to radians, and from radians to degrees. Geometric functions are available for all vector types, and so you can take the length of the vector, you can measure the distance between 2 points described by 2 vectors. You can also find the dot product, the cross product. By the way, dot product returns the scalar value, cross product returns another vector. Okay, and it's available for a vector of 3 components. Normalize vector takes vector and returns a vector. Use the specific type here, but when you normalize, normalization brings the length of the vector to 1 unit size. So the direction, of course, remains the same, but the size of the vector, the length, changes. Reflection and retraction, I googled this, and this is the image of the effect of reflection and refraction. That's sort of like a ray of light going through the glass-like material. So here you have to have the normal vector and the incidence vector, and you combine them to the two of them together, so you have these two reflection and refraction functions available to generate this resulting vector that you're trying to compute. Okay. So there's also face forward function, which is also considered to be geometric functions. And with every new version of GLSL, you may find new geometric functions and other functions to be part of its specification. So, of course, this is just a set of very basic examples right here. More common functions that you would find in mathematical libraries or your spreadsheet application, such as absolute, obtain the sign of the value, floor, ceiling, modulus, minimum and maximum of the two values. There's also truncation, that basically finds the nearest number not larger than the absolute value of x. Rounding is available, just basic rounding based on 0.5 rounding up. Also round even, it's a bit more complicated rounding. Right here you can read the description. You can also take a floating point number and obtain its fractional part, right after the radix point, after the decimal point. Clamping the value, mixing for blending colors, for example, is available. Stepping also is available here. So just read the documentation online. Of course, if you need to use these functions, you have to experiment with them and give some time to research all the parameters and how it works mathematically and geometrically, and how you can apply it in your shader code.